So, like I said before, what we're starting on today is order of operations. How many of you guys remember order of operations? Anyone? Yes? No? Some, yeah. A lot of you might remember the phrase PEMDAS. Does that sound familiar to any of you? I got some kindas and yeahs on the order of operations. PEMDAS has ultimately been our order. I prefer to think of it in terms of GEMDAS. And the reason is what did the P stand for in order of operations? Parentheses, exactly. But the thing is it's not just parentheses that comes first. It's any grouping whatsoever. So I like to think of it in terms of groupings, right? Which means brackets and parentheses. You'll see things like this or parentheses. Another thing that most people don't understand too is that that divider line on a fraction is also a grouping. One grouping would be at the top of the fraction and the other grouping would be at the bottom of the fraction. Right now it looks like a division symbol. It's not a division symbol. We'll call this like N M or whatever the grouping is. But what is on top of a fraction and what is on the bottom of a fraction are separate groupings, right? So we would handle one of those groupings first and then the other one next. Which is why I like to think of it as GEMDAS. You could still remember P for PEMDAS because it's probably ingrained in your brain. But remember, it applies to any grouping, right? Not just what's in the parentheses. It could also be like absolute values as a grouping, right? The next one, E, is for exponents, right? Things raised to a power. But one thing to remember is exponents, square roots are exponents. This is an exponent. It means something. Like if I had an x here, this would be x to the 1/2 power. A cube root would be x to the 1/3 power. So square roots would also fit under that exponent category. Multiplication and division, I wrote together because a lot of people think that multiplication comes before division. And I don't know if you've ever seen like those math problems that they put out like on Instagram or Twitter or whatever social media thing you look at, where they're like, solve this problem and everyone's got a different answer. And a lot of it falls in the fact that people think multiplication is before division and that addition is before subtraction. But these are whatever order they come in, left to right. If you're reading it left to right, whichever comes first, right? So if multiplication comes before a division, then the multiplication would be first. But if you saw a division before you saw the multiplication, the division would come first. They're equal. Same thing with addition and subtraction. Equal, read left to right. Left to right. My handwriting is terrible on this whiteboard. I've got to do something about that. So does that make some sense to you? Because we're going to play with some of these a little bit so that you can kind of see how they solve out and how we would read them. So my first example would be, ooh, that is a thick pen right there. Let's see if we can make that thinner. Let's try that. So my first example would be, what if I have 29 minus 11 minus 2 cubed plus 6 squared divided by 4. Let me make sure I wrote that down properly. Okay. So when we're looking at this problem, the first thing we're going to deal with is that grouping inside there, right? We've got that 11 minus 2 cubed. Well, that's an exponent inside there. So I've got 29 minus 11 minus 2 cubed is 2 times 2 times 2, which is 8. So minus 8. Plus, we can go ahead and do this exponent right now because it's going to come before the division, and we're going to say 36 divided by 4. And then we have to deal with what's in this parentheses, right? 11 minus 8 is 3, so we'd have 29 minus 3 plus 36 divided by 4. What's going to come next? So we've taken care of our groupings. We don't have any more groupings. Do we have any more exponents? Yes, no, maybe, no. No more exponents, right? We took care of that. Multiplication or division left to right. So the first thing that we come across, we don't have any multiplication here at all, but we do have division at the end. So we've got this 36 divided by 4. So we wind up with 29 minus 3. 36 divided by 4 is 9, and it's positive because these are all positive. So I have 29 minus 3, which is 26, plus 9 equals 35. Does that make some sense in how you would deal with problems like this? Sometimes you're going to get crazy stuff. Like if I have, I'll do one more example in terms of these before I move on to evaluating. If I have, for another example, let's do something super crazy. The problem is so crazy I can't even read it. So we don't want to do anything that crazy. What if I have 7 minus parentheses the absolute value of 10 minus 12 plus 5 squared over 9 minus 2 squared? The reason I like this problem is because it's got the fractional thing. So we can look at, there's 2 sets of groupings, right? There's the one on top of the fraction, and then there's the one on the bottom of the fraction. And the one on top of the fraction has another grouping in it. And we're going to deal with those groupings first. We're going to reduce them as much as we can before we move on. So I've got 7 minus, and I'm going to deal with this grouping first. I'm not going to be able to get the whole grouping at once. Here I have the absolute value of 10 minus 12. Well, 10 minus 12 is negative 2. And the absolute value of negative 2 is just 2. So I'm going to have 2 plus 5 squared. Well, what's 5 squared? It's 5 times 5. So 2 plus 25. And that is my whole grouping up there right now, right? We'll figure the rest out in a minute. But here I have 9 minus 2 squared. Well, that's just 9 minus 4, right? Which is 5. So we can make some room there, right? 9 minus 4 is 5. I still have this grouping that's 2 plus 25, right? So we're going to call that 27. And ultimately what I have is 7 minus 27 over 5. 7 minus 27 is negative 20 over 5. And now we can do our division, which is negative 20 divided by 5, which is negative 4. So it's a lot of steps, right? That problem, you might have looked at that problem and thought, I don't know where to start. But if you just take it, you just take it one piece. Can you hear that? You can't hear it? Okay. I can. I wish I couldn't. Um, so if you just take it in pieces, it's not as bad. The arithmetic itself is really simple arithmetic. It's just looking at that problem and not being overwhelmed by how much you see in it, right? Because we're always going to make it something smaller in the end. So in your delta math, you're going to be dealing with order of operation problems, and it's going to, I can't remember how they worked it in there, but I believe it's like what comes next type of thing. It's not really a solve it out thing. There might be a little bit of both in there. The other thing that you're going to have to do in your delta math is you're going to have to deal with evaluating expressions. When we're evaluating expressions, it always means the same thing in math. When they talk about evaluating in math, they're always going to give you something to plug in and you have to solve it. It's not super hard, but it's going to require your order of operations, which is why I like to teach it together. But when we're evaluating expressions, and anytime someone asks you to evaluate something in math, they're going to give you a value that you plug in and you got to try and get the answer. So when we're evaluating expressions, if I have an expression that's like a times b squared over c plus 12, right? We have a lot of variables in there. But what if they tell me that a is equal to 3 and b is equal to negative 4 and c is equal to 8, right? If that's the case, all we have to do with this expression is to plug those in where we see those variables and then solve it like any other math problem. Where's my, I have to go all the way to the top to find my thing. Just want to change colors, man. My little toolbar disappeared. There it is. So if I have this expression right here and I go, okay, well, I've got that a times b squared on the top. A equals 3, so I have 3 times b squared. Well, b is negative 4. I'm going to put that whole thing in parentheses. And the reason that I would put that in parentheses is that if I don't put it in parentheses, I'm only squaring the 4 and not the negative. Does that make sense? If I didn't have it in parentheses, we would wind up with a negative number. But if we're squaring negative 4, we need to multiply negative 4 times negative 4, right? And we would get a positive solution. Where if I wrote it as negative 4 squared, in a circumstance like that, we would get a solution of negative 16. But really, we're squaring the whole thing. The whole negative 4 is being plugged in. So we're squaring that negative 2, and a negative times a negative equals a positive. Does that make some sense? I see a few head nods, so I'm going to assume that's a yes. All right. C, we have 8 plus 12. And now we're just going to use our order of operations. It says to deal with our groupings first. The only grouping I have is what's on top here and what's on the bottom here. Those are my groupings. I can't really deal with this grouping though until I've done the squaring, right? So I would have 3 times 16 over 8 plus 12, which is 20. 3 times 16, I think that's 48. I'm pretty sure that's 48. 48 over 20. And then we just have to reduce our fraction, right? Do you guys remember how to reduce a fraction? No, maybe so. I think each of these is divisible by 4 is the biggest thing they're both divisible by. So this would be 48 divided by 4 is 12. 20 divided by 4 is 5. If you can't think of the thing and they're both even numbers, start by dividing by 2, right? If you don't know what their greatest common factor is to reduce them, start dividing by each of them by 2. They're both even numbers, right? I have a pet peeve. My pet peeve is not reducing fractions when there's an even number over an even number. Like I'm forgiving when the numbers get big and you don't know, but if they're each even and you don't at least divide them by 2 to reduce them, like I'm not very forgiving on that one. I'm also not like super penalizing on it either, but it's one of those things that you should get in the habit of. You should reduce your fractions when you can. Any questions in terms of evaluating? When you're evaluating, the rule always, right, is just to plug in the numbers and then do the arithmetic. It's like getting double quizzed on order of operations, right? In terms of like once you plug those numbers in, you do have to use the order of operations to solve them. So you're going to have a section in Delta Math on orders of operations specifically, and then you're going to have a section on evaluating equations that's going to require you to also use order of operations. It's really the whole lesson for today. Any questions regarding any of it? Does it make sense? I know none of it's new, but it's also been a while since you've done it. Well, then if there's no questions, I'm just going to have you guys do a problem and put your solution into the chat box. And then once everybody's put it in, like that's going to be your participation points. You guys really need to do the participation questions when you have them, because I don't know if you've noticed on Aries, but they're worth 25 points every time you do it. And it's how I know that you're paying attention the entire time. So here is going to be your chat box question. Pretty soon it'll be a whiteboard question, but I haven't gotten all that set up yet. Your chat box question is going to be 3r minus 4s. That's an s. 3r minus 4s, where r equals 5 and s equals 2/3. So I want you guys to work that out, come up with an answer, put your answer in the chat box when you get it. I will tell you right off the bat that it's not a whole number answer. You're going to have a fraction answer. So that's 3r minus 4s, where r equals 5 and s equals 2/3. Aiden, Trace, Michaela, all of you are supposed to be on camera. So I'm seeing a couple different answers, but actually all the couple different answers that I see are actually the same exact answer. Right? Some of you just wrote it in terms of a mixed number, and some of you wrote it in terms of a fraction, but it looks like everybody who submitted it got it right. So I recommend neither of them are wrong answers. I want to let you know that they are the right answer. 37/3 is the correct answer. 12 and 1/3, same thing, right? It's just written as a mixed number. Um, the higher you get in math, the more you want to write the mixed the improper fraction number. It's easier to work with in math. So the 12 and 1/3 you wouldn't have to do. You could leave it as the 37 and a third, 37/3. Simply because if you have to do anything else with it, it's easier to work with when it's not in the form of a mixed number. But I also don't want to say, hey, it's wrong, because it's not. It's absolutely right, the answer. That's it. That is your participation. Everyone who actually put something in on that board will get credit for it. I don't have anything else for you except, you know, keep an eye on that Delta Math assignment. It's already posted. It was posted this morning. I'm going to be setting up tutoring hours probably by the end of the week when I see what my new schedule is going to look like. I have some blanks in my schedule, and I think they might be putting a class into one of them. So I'm not really sure what my schedule is going to look like, which is why I haven't posted tutoring hours yet. So keep an eye out for that. I'll always have some in the afternoon as well, but I just need to figure out what they are. The good news is like we haven't gotten into anything too complicated yet, which is one of the reasons we haven't, is that I'm trying to keep it a little more on the simple side while we're figuring out what my schedule will look like, because I want to be able to actually provide you guys some time. I guess I could stop recording now.